Hi, I'm Philippe. Welcome to Occitanie, where we make waste valuable.
Europe does not need mountains of trash, but it does need greener energy. In southwest France, waste is being transformed into energy, fuel, and economic return for the citizens who produce it. At the Trifyl waste management facility, household waste collected across the Tarn Department is treated as a resource, where recyclable and organic materials are separated through advanced recovery processes designed to extract maximum value. Organic waste undergoes anaerobic digestion to produce biomethane, which is injected directly into the local grid. Waste that cannot be recycled is converted into RDF, or recovered solid fuel, which is used by local industries instead of being sent to landfill, while heat is also generated through the facility's boiler system. By combining recycling, fuel production, and energy recovery in one integrated system, Trifyl recovers or reuses more than 80% of the municipal waste it processes and supplies around 10% of Tarn's natural gas demand. Enlit On The Road visited the Occitanie region to explore how waste is turned into a local energy asset.
Philippe, thank you for welcoming Enlit On The Road to Occitanie. Am I correct that we are actually sitting on trash at the moment?
Yes, that's true. We are sitting on more than 1 million tons of household waste that has been put here in the landfill for some years. This was the old way of treating the household waste in our region, and now we have the new plant that is producing gas and solid fuel from the waste, and makes it possible to divide by 5 the amount of residual that will go finally into the landfill because not valuable. The technical challenges of this sort of plant is the multiplicity of the different processes that we have here.
So what exactly is happening beneath our feet at the moment?
So in each cell in the landfill, you have the organics that is being degraded into biogas. This biogas is collecting in these pipes with the wells and then sucked with a blower to be sent to CHP engines, which produce electricity and heat from this biogas. This old way, it takes for one cell, which represents roughly 200,000 tons of waste, it produces gas during 20 to 25 years. In the new way of valorizing the waste, we produce the same amount of gas in 3 weeks. All the organics are being degraded in 3 weeks. And so the same amount of gas will be produced in the plant in 1 year as it would be produced here in 20 years with a different volumetric efficiency.
So am I correct in understanding that the ground is actually sinking?
Yes, because with this degradation, the waste are being more and more compacted, and so the ground is moving down slowly during all this degradation time.
What is the future plan then for this land?
So when the landfill is closed like this surface is useless. You cannot build nothing on it. So we will install solar panels to valorize this surface to produce solar electricity. And it is a specific technology to compensate the moving of the ground and to keep the solar panel stable. So this is the RDF boiler. So the RDF is what is produced as a fuel after the digestion process from the waste. We burn one half of what we produce here in this boiler to provide heat for the different consumers of the plant. The consumers are the digesters. They need to be heated to make the biogas production. Then we have the dryers, tunnel dryers or belt dryers to prepare this fuel, and also the pasteurization process to remove the wrong bacteria after the digestion process, especially for the food waste digesters. This is a sort of classical biomass boiler, but which is adapted for the RDF combustion. And you produce hot water at 130 degrees C, and we have a second loop at 90 degrees C. This RDF boiler is one thing that is unique in this plant, because this boiler already exists on other kinds of RDF, but more coming from industrial waste. And here coming from the household waste after a digestion process. It's quite unique in Europe. So after the 2 mechanical treatment lines that we see, all these machines are preparing the organic matter to be fed into these fermenters. Here, you prepare the organics and then you inject it in the fermenters. And you need 3 things for producing biogas. You need temperature to have the bacteria at the right temperature. You need a good preparation of the material to have the bacteria to be able to degrade the material. So you need to shred it and to have a small grain size. And then you need to have a good homogeneity in the reactor. And due to that, you need to make a mixing. Sometimes it's done mechanically with the stirrers that make the mixing inside the fermenters. Here it is done through injecting gas, the biogas that you produce. You compress it, you store it, and then you inject it from the ground of the fermenters. You make some high pressure injection so that you have these bubbles that makes the mixing inside this big tank.
What does this say about the role of biomethane gas in the future energy mix of Europe?
Well, what is interesting in gas is that it is something that is used in all the industry for years and years. We have all the infrastructure, all the networks to deal with it. We do not need to change anything, but when you produce green gas, you just produce gas that will not lead to fossil CO2.
So would you say that it really increases the resilience of the local community?
Yes, because you reduce your dependency to these importations, and with this RDF, we can also sell this RDF for any heat production on the territory. So it's a way of getting our energetical autonomy in this territory.
Philippe, thank you so much for sharing your insights with us today. For more insights, join the Enlit community.